Hello, my name is Noah, and I'll be going over my part of Sprint 2 for Nestor FS. Jumping ahead to the burn down and retrospective review for things that went well to me, I was able to complete the Bloom filter implementation along with finalize the cross OS and cross directory compatibility for my parts of the project. For room for improvement, I was unable to, or I noticed issues with a possible clash of map names in the way that I handle mapping files within my Git file function call. The primary issue I would have there is the possibility of clashing data when updating the map. If two files have the same name, then they could update one another in the map, and then I could have clashes there. Jumping into breakdown of labor, for myself, I was able to complete again the hash-based virus scanning along with cross OS compatibility. I was unable to complete a debloating section along with file shredding. In total, it took me about 8.5 hours. I estimated around twice that though. The primary issues there are just being unsure of how to proceed with the debloating process and partially being unsure if we're going to implement that. And then file shredding, just not having a good idea of how I want to possibly handle it. For my impediments, again, going over this for shredding and debloating, partially choice paralysis for the method of shredding and an unclear method to approach for pursuing the debloating. As for action, I'll be researching my shredding and deletion options along with investigating options for how we can handle post imaging of a computer and how that would handle the software debloat there. Moving on to my live feature demo, I'll be going over the hash-based virus scanning and go ahead and transition to Visual Studio. Excuse the slightly awkward method of presentation here. I'll quickly go over how I set up the bloom filter. For a quick overview, a bloom filter is essentially just a chance or probabilistic method of checking for set membership. To that extent, I'm using it to check the hashes of precompiled lists of known malware. That's just a large set of files that contain precompiled hashes of known viral data that the Bloom filter compiles into a list that can be checked in OFK lookup time. Using a generic class, the Bloom filter, I use a bit set to store the data, and then to check if the member is contained, we have a contain to check and see if the given hash exists within the Bloom filter. This is not a guaranteed method to, or excuse me, this is a method that has guaranteed positive values on values that match its contents. However, there is a chance that it may result in a false positive, which would just mandate doing a double check on the file, which is handled by another user for the project. Essentially, this just works as a probabilistic guard. It can reduce the expectations for having to hash everything all at once or each individual file and then check that against every single entry within the known values, just reducing some of the lookup time required for that. To briefly go over an example, I added some known hashes or some hashes that I composed from some of the files here. If I go to my runner, this just uses the working directory for my code. Use the edit in content here. I just went ahead and updated the print function to show more information about the file. If I go ahead and run this, then we can see that we get a possible virus on this first value here. In this case, it is the file Trino class, so that is this one right here. So we can see that this hash 193 matches the hash that I added to the viruses folder. So again, this is just something that I tossed in here to show that this does work. And then none of these other hashes are present within either of these files, just showing that this does return mostly good values, and we have a possibility for receiving some false positives. And then moving on for the next sprint. Hopefully next sprint, I should be able to demo file shredding and possibly software debloat, or at least the basics of looking into that so far as determining what files are candidates for possible removal with debloating. But other than that, that's everything for my part of the presentation. I'll go ahead and call it here. Thank you very much, and bye.